Okay.
Like starts out weird, but then it takes a while.
All right, let's get ourselves
Okay,
situated
yeah, I just
and see what we've got going on here. Whoa, 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 hold on. All here. Okay, you take off your hood, sweetie. Thank you for being here. We're all here. Yay. Start that. And then I turned back some papers. Does anybody have a question about something on the homework? It seemed like I was marking quite a few things. One of the things I was marking is when you are writing a formula or when you're expressing a sub n, for example, on number, I'm looking at the homework 2.1, number 2, and it's, you had to find an expression for a sub n. You guys used your formula for an arithmetic sequence, which is absolutely perfect. But then, clean this up. This is not good. Clean that up. So, a sub n equals 6n minus 1 or negative 1 plus 6n. That's what I mean by cleaning it up, okay? And then the other thing I remember marking some is, for number 3, when you had to find g sub 11, the 11th term, in other words, let n be 11, it's geometric. What is the first term? Well, be careful. What is the first term? I'm looking at 3, number 3 on homework 2.1. Sorry. That's okay. First term is 4. A sub 1 is 4. Now you might look at the thing and say, no, the first term is, what is it, 8? But what is the x coordinate for 8? 0. And when so that would be like your a sub 0 term. And when you're writing your formula, if you're using what we normally use for geometric sequences, you need the first term. So that's a sub 1. So that's 4. And then what did we decide our ratio was a half to the 10th? Now, if you just type that in on your calculator, which is perfectly fine to do, you get some crazy decimal. Just math frac that so that you don't have any round off error. There's nothing wrong with fractions. Fractions are fine. So you just math, your math button, and the first option is frac, and there you go. All right, was there anything else? I can't remember. What else I was marking there? I can't.
Number 7.
Number 7. With each stroke of a pump, 10% of the air in the tank is removed. How many strokes will be required to have less than 20% of the air remaining in the tank? Okay, so what does that look like? Okay, so this is, I'll just say 100% is how much air is in the tank when I start. So then after I pump one time, so I'll say pump 1, how much air is left in the tank? 90%. 90%, okay, so 0.9. And then after I pump twice, how much air is left in the tank? 0.81. Because how are we finding the remaining air in the tank? Well, if we're taking out 10% of it, we are keeping 90% of it. So would everybody agree this is geometric and the ratio is 0.9? So now we just need to figure out how much, or no, when will we have less than 20% of the air remaining in the tank? Okay, so this gets a little bit tricky. Somewhere down the line, there's going to be a 0.2, right? Or something close to 0.2 down the line. I need to figure out when that happens. So what makes this a little bit tricky is we have to, it's gonna be hard to figure out exactly which term that is. Who had an idea? Who had an idea? Well, after one pump, it's 0.9 to the first. After two pumps, it's 0.9 to the second, and so on. Would you agree? Okay, so I want to know after how many pumps it's that. Does that make sense to you? So 0.2 is 0.9 to what power? Isn't that basically what I'm trying to figure out? Think about it. The first pump is 0.9. Second pump is 0.81. So nth pump needs to be 0.2.
So we're getting a 0.81 because it's, you're subtracting.
0.9 times 0.9. We are multiplying by 90%.
Because there's gonna be 90%
Left.
Okay.
And that's what the question is. I want to know how much is out. I want to know how much is left. So I'm multiplying by 0.9. Okay? Anytime a percentage is involved, guys, it's probably going to be geometric. So don't be doing this as an arithmetic because you're not taking out the same amount each time. Okay? Now, how do I solve this? Well, what do you mean, Sandra? What are you talking about? No. Can I graph these on my calculator? And look for where they intersect? Absolutely. Now, some of you impressed me because some of you did this. And you and I haven't talked about this yet, but you surely did it last year. And that will also work. I used LOG, you could have used LN. It doesn't matter what logo you use. So at this point, you are either going to graph this equation and see where they cross, or you are going to take the logarithm of both sides so that you can pluck that exponent off and do the division. So when I do the division, since that's less time than graphing it, I get 15.27. This equals 15.27. Those of you that are graphing it, you should be getting something close to 15.27. So how do I answer the question? When will there, after how many pumps, will there be less than 0.2? Won't I need to go to 16 pumps? Because 15 will be more than 0.2, so I need that 16 pump. Okay? All right, well, let's put that away. Remember, my answers are always up here. You're always welcome to come and compare yours to those at any time. Let's get our notes back out. We're going back to 2.3. And we're just beginning some of these very beginning things about exponentials, but they're very, very basic. So I'm looking at, this is kind of a textbook page almost, and here in the middle, he talks about exponential growth and exponential decay. Now, clearly, you guys, those words make sense in terms of the picture, right? So how do I know, I mean, obviously when I have a picture, it's easy. How do I know when I have an equation, whether it's growth or decay? Well, what are your thoughts on that? Here would be an example of an exponential growth, and here would be an example of an exponential decay. Why is this one growth? as I keep multiplying by 3. And when you keep multiplying by an extra 3, remember, the exponent is going to be 1, and then it's going to be 2, and then it's going to be 3. So you keep multiplying by an extra 3, obviously, yeah, you are going to grow. What's happening here? I'm multiplying by an extra 1/3, which means it's just going to keep getting smaller, right? So that's how you know. When you look at your base. Remember, the base must be positive, but it can be less than 1. And if that's the case, you have a decay. Now, look at these pictures. They're always either increasing, this guy is going to be increasing always, or they're decreasing. So therefore, they are always either concave up or concave up, right? If we don't make any changes out here, because obviously if we put negatives out here, that's going to change, flip it upside down. All right. Let's look at the back side, example 1. Here we go. Write limit statements for each of these pictures. We haven't done this in a while, but we need to remember how to write limit statements for any behavior. Everybody remember this? The limit as x approaches negative infinity and the limit as x approaches positive infinity. So this one's on the left, this one's on the right. Left, right, right? So tell me for question A, 1A, where are we going to the left? Closer to 0. And where are we going on the right? Positive infinity. All right, see if you can do B and C on your own with your partner. Make sure you're writing the appropriate notation. Please don't get lazy. Don't get lazy. Write your appropriate notation. Different picture than we looked at on the front side for sure. But what's happened with B? Haven't we just taken one and flipped it upside down? Okay. So what do you think for B? What's the limit as we go to the left? Negative infinity. Beautiful. And what's the limit as we go to the right? 0. You are wonderful. Oh my. C isn't a picture. C is an equation. All right, let's see if we can think about this for a second. This is important. What does that tell me? Decay. That's going to be decay, right? So decay, remember, looks like this, decreasing. So the limit on the left is going to be infinity, positive infinity, and the limit on the right is going to be 0. Is that okay? All right, let's talk about, determine if it's increasing, decreasing, concave, up, or down. Okay, picture A. Would you say that is increasing or decreasing? Picture A, 2A. Decreasing. Remember, you're moving left to right. Isn't that thing going down? So that's decreasing. Would you say it's concave up or down? Concave up. Beautiful. All right. B is one of those upside down ones. So would you say that's increasing or decreasing? Decreasing. And that one is actually going to be concave down. Agreed? Oh, now we have an equation now, so h of x, so think about this, think about it now. The base is 4. So what's this one doing? Increasing. Would everybody agree with that? It's increasing. And because of that, it's going to be concave up. Example 3. Another one of these little charts. Determine if f could be linear, quadratic, exponential, or none. Now, please, what's the very first thing your beady little eyes are checking? Your x's. That's right. Check your x's. Are your x's increasing at the same rate?
Yes.
I mean, are they? Yeah, so we're good. Go ahead and just look at your y's and analyze what's happening. What's happening to your y's? Where are they going up? Let's see. The change from 3 to 5, the change is 2. And from 5 to 9, the change is 4. And then 9 to 17, 8. And 17 to 33 is 16. How are those changes changing? Aren't they changing proportionately?
Yeah.
And if your rate of change is changing, if those things are changing proportionately, then what kind of function do you have? Exponential. That's exponential. If those numbers were all the same, we would be linear. If they were going up linearly, so in other words, if you were finding those changes and it was 2, 4, 6, then that would be quadratic. But when these changes are proportional, that is, you keep multiplying by the same thing, then you're exponential. Okay, so let's make sure we're clear on that. If it's 2, 2, 2, 2, you are linear. If it's 3, 7, 11, you're quadratic. No, that's not right. Yeah, that's right. 3, 7, 11. That would be quadratic because they're going up by 4s. If they're going up by multiples of 2 or something, then it's exponential. Okay, as long as those x's are the same. All right, perfect. We're not doing this next thing because that's some kind of a small thing. But let's go to the back where we're going to check our understanding. So a billionaire hires you to mow the lawn. For pay, she's going to give you a penny for the first job and double your pay each time you complete a job. So you know where this is going eventually. All right, go ahead and see if you can figure out the answers to number 1.
Yeah, no, you're right. No, yeah, that makes more sense.
All right, what'd you get for A? How much money would you expect to make on the first job? 4 cents, easy. I came up with this as my nth term. Does that seem okay with everybody? Now, you can use 1.48. I chose to go with the decimals because down here I had to put in a dollar amount. So it made sense to keep that as dollars instead of cents. Okay, so how does this look as a setup for C? Does that look right? So we just talked about a problem like this. What are your choices? You have to solve this. What are your choices? You could log both sides. Now, time out. If you're gonna log both sides, then there's a first step. If you're gonna take the logarithm of both sides, you must divide by this number first. So if that's what you're gonna do, you're gonna divide by this number first, okay? All right. What else could you do? Graph and look for where they intersect, right? Now that is a million, so make appropriate window changes, but one or the other. All right, I haven't done it yet. Let's do it together and see what we come up with. I got 28. Did anybody graph this? Anybody graph it?
Yeah.
Did ya? Did you get that?
Yeah, I got 7.5.
Yep. So it would be the 28th job that we take over.
So how'd you solve it this way?
All right, here we go. Identify whether the following scenarios represent exponential growth, decay, or neither. Give a reason for your answer. You buy a car that loses 20% of its value every year. Decay. What's your ratio? What's your base, your B in that problem? 0.8. No, A is whatever you bought it for. And when you look at our, this is called the base, okay? That would be 0.8, right? Losing 20%, 0.8. A restaurant job shares 3% of its total sales for each shift with its employees. Well, I'm not sure because for the employee, that would be growth, right? But for the restaurant, that would be decay. So, I don't know. Restaurant decay, employee growth. Battery life on your phone decreases by 10% every hour. Decay ratio would be 0.9. You deposit money into an account that pays 4% interest. Growth, and what's your ratio? What's your base? 1.04, because it's growing. It's growing 4% additional, 1.04. The initial population of rats was 20 and grew to 25. which of the following functions best models the population of rats with respect to years T if the population is considered to be exponential? Well, stop. If it's exponential, we're getting rid of A and we're getting rid of D. Would everybody agree with that? A is linear and D is quadratic. It can't be those. So which do you think it is? Why do you think it's C? It's a good guess. If it's exponential, kids, that means that we multiplied by something to get from 20 to 25. How could we figure out what we multiplied by? Divide? So what's 25 divided by 20? 1.25. So we multiplied by 1.25. So therefore, my equation will be 20 times 1.25 to the t. Does that make sense to everybody? All right, now, I should have printed these in color, but it costs too much money, so I didn't. And I've got some colored pencils, so what I want you to do, if I can get my I want you to color on the next page. There are a bunch of curves, and maybe you have your own markers and pens, that's fine. If you don't, I'd like you to color each one of those in a different color. Because we're going to be comparing these curves, and it's just so much easier if they are different colors. So, go ahead, either grab mine or grab yours, and it doesn't matter what color you use. It does not matter which color you use. But I want you to be able to talk about distinguish.
Are they erased?
Like, how are you? I was like, oh, dude, Bryce, you're actually funny. That's crazy.
What did you say? You said root.
I love this.
My sense is causing me to really
Love this.
But I want to sorry about
Like everyone like goes.
That's Swiss Army.
Swiss Army. Did you get from Swiss Army?
Or you just have staring problem.
Wait,
Pick it up, pick it up, pick it up. That's it.
Always has some.
Now that, yep. Bingo.
Hey, some of us failed.
You failed coloring.
So these can be negative. Yeah.
I didn't learn how to time it now until like 4th grade.
Yeah.
I'm going to 4th grade.
There are two exponentials that are counted on here and two that you know of them.
All right, how we counting? If you're done coloring, then the first task is to figure out which of these lines are which. So here are your functions, and you gotta figure out, for example, like what's my blue one, what's my pink one, which of these goes with which. So see if you can start labeling your lines, your curves. W, G, H, J, and K.
Oh, that's a good point.
Okay. W and K are. So wait. So I'm guessing it's each line right here. 2, 8 is in the middle.
What do we notice about our functions here, guys? This guy and this guy are what kind? They're linear. So, did you notice in your picture you have two linear ones? And what's the difference between your linear equations? One of them is going up and one of them is going down. Now, let's look at the two we have. Isn't this line going up? So J has to be, for me, it's purple. I don't know what it is for you, but it has to be that line right there. Would you agree with me? And that means that J must be my green line. Now, let's stop right there.
So you did flip-flop.
Oh, that's
Or no, you just did J.
J's purple.
Yeah, J, G? Thank you. This is G. Thank you. So are we okay with that? All right. Now, what about these exponentials? What are you thinking about there, Drew?
There's only one decay, and there's two exponentials that have positive, or like.
Bigger than one. So, Drew says, look at W, for example. What does that tell you? It's growing. So doesn't it have to be either my black or my pink? Well, what about this guy? Isn't he also growing? Okay, so he's either black or pink. Now, how am I gonna decide which one's black and which one's pink? Which one's increasing faster? 3 is gonna go up faster than 2 is, right? Timesing by 3 is more than timesing by 2. So black must be K, because he's getting bigger faster, and pink must be W. And process of elimination, that leaves blue as H. So let's stop right there with everybody. That logic makes sense to everybody. Okay. Order the following from least to greatest. So in other words, at x equals 1, which I don't know exactly where it is, but if that's true, then we want to be like halfway in between. So like right here is where x is 1. Are you with me? So I'm going from least to greatest. So what's the least?
W.
My pink, which is W. And then my black, which is K. Are you following along what I'm doing here? And then purple.
Wait a second. Oh, wait, is it K?
The red line, or no, the black line goes like under the pink line.
Uh-oh, the black one.
It goes like under the pink one. I don't know.
The black one should be under the pink one. More like that.
Yeah.
Okay, so that changes things. So K should come first.
Yeah.
And then, are they both under my line? Okay, so then comes J. Alright, and then comes H, and then G. How does that look? Does that look right now?
Or like over here.
So are we good here? I messed my picture up and now it's nope. Is it all right there? All right, now we're doing the same thing, but we're doing at 100, which is way out here someplace. All right, so which is gonna be the smallest as we go to 100? The smallest is going to be G, isn't it? And then is going to come H. Now remember, H is exponential, so it's going to keep going down, but it is going to actually curve. Where's H? It is going to keep curving, but it's going to stay on top of the x-axis because it's approaching 0. This line is just going to shoot down into oblivion, right? So definitely G is the smallest, and then H. Okay, then what? J. And then W, and then K. Because K has a bigger base, so it's going to shoot up faster. Perfect. Number 4. K of 15 divided by K of 13. So K, here's function K. What do you think about that? Emily, what's your thought?
Would the F's cancel out once you set them up?
Absolutely they would, because K of 15 is just gonna be F times 3 to the 15th. And K to the 13th is just, or K of 13 is gonna be F times 3 to the 13th. So absolutely those F's are gonna cancel. And a whole bunch of 3's are gonna cancel, leaving you with what? 3 to the 2nd, which is 9. That makes sense, because how is, what is it, function K? How is K operating? We just keep multiplying by an extra 3. So when you do 15, you've got 2 extra 3's that you multiply by. All right, j of 15. J of 15, so that will be E plus 15 would be 45. And J of 13 would be E plus 39. And I'm subtracting them. What's going to happen to those E's? They're going to be gone. And we're going to be left with 45 minus 39, which is 6. Does that make sense? Yes, because how is J working? Every step J takes is another 3. Just keep adding 3. Well, if you go 2 more steps, at 15, you've gone 2 extra 3's, which is 6. Perfect. Find the values of A, B, C, D, E, and F. I'm going to give you a couple minutes to work on that and see what you think. So see what you can come up with. All of these constants now. You're going to figure out what all of these things are. Don't just sit there. I heard somebody say, I have an idea. Let's get some ideas. Yeah, I think just a little out of it. Okay, well, we got this fun problem. Let's do it.
We're gonna find out how it gets into. I think is y intercepts is 2. Look at the here. 18 gets down to E, going over to 2, so it's 10. So we're gonna put 5, so
Anybody over here have my colored pencils?
yeah, I think.
You're trying to steal my colored pencils. This is lost and found for 3 years.
Oh.
You guys have my colors?
Wait, we just need to find the value of when it crosses the x-axis, and because it intersects with g of h, we already have the equation for g of h, so we just find what g of h equals, what g of 0 equals, and then that's that value, so then we have the value of c, and then we did the same thing that we did with k of x for that one.
It would just, wait, that's just 8.
So we know c is 8. Yeah, because
That's the one you said.
yeah.
Okay, so C equals
Yeah.
how is that?
It's obvious.
No, c is 18 times d of x, then you do, like, why do you have d squared?
Because the x is 2.
Why is the x 2? Why are you doing that?
Oh, you're talking about using those points instead. Oh,
Yeah, I was using
okay.
this point, because this is what x equals, so it's just x. So it's just like, c is just 18. Yeah, and then, so then you have the equation
Oh, I see.
equals 18 times d of x.
Okay, so 18 equals 18.
wait a minute, anybody found any, let's start with A letter, what was the first letter you found?
Yeah. Intercept
A was the first letter somebody found, tell me,
is the value.
how'd you find out?
But
You said it, Mr. Ron. You said that, oh, how'd you find
Oh,
out?
so you're saying like second equal to each other.
Well, went to J,
I just found one and zero and knew that the Y value
well, no, not
Okay, how'd you find E?
of because they're intersecting.
I went to
So that
J, like the line of J. I used the slope of
it's just
three.
it's x minus
I
y.
just kind of
This
found
would be
the X or the Y intercept from there. It was that Y
this
intercept.
would be
So
the
that
value
point on the
of
Y
x
intercept would be 0, 2. And I just put the points in.
because x is
So
zero.
E would be 2.
This equals
Okay, he found out E would be 2, does that agree with what the rest of you did?
Yep.
So you could have, remember this points to all of them, Kyle, so what you did was fine. But you could have simply said 8 equals E plus 3 times 2.
Yeah.
Since we know that point, you counted back, okay, that's all right. The E is definitely 2. All right, perfect. So J, just point right here, is the point 0, 2. Okay, all right. Somebody else, how did you find another letter? What'd you find next? Anybody? What'd you do?
oh, we just solved it.
What was that?
The rest of them except
Over the rest of them?
yeah.
So this line would be easy because again, it goes through that point. So 8 has to equal 18 plus 2b. So negative 10 equals 2b, so that b is negative 5. So b is negative 5. Alright, and then Bryce, what did you say you did that for W?
No, we didn't. The only one that we didn't do was that for A.
So you did do that for W.
Yeah, we did do that.
Okay, so you said 8 equals A times 2 squared?
Yep.
We're just plugging in that point. So your A, let's see, that's 4. Did your A turn out to be 2?
Yep.
And then down here, you said 8 equals F times 3 squared. So this came out to be 8/9?
Yep.
Wow, everybody okay so far? That point really came in handy, all right. What did you do for me? Yes, ma'am.
So we looked at G since G and H intersect at the Y, and the Y intercept for G was 18. So we plugged 18 in for C.
18 in for
C.
C? Oh my gosh, somebody's been paying attention. Good work. Because in an exponential, this guy is your initial value. That's the value when x is 0, right? So that is going to be 18. Very nicely done. So then what? Then what did you do? Then what did you do?
So we divided we like plugged in 18 for C, and then we divided 8 by 18 to get 4 9.
So you came back to this point
Yeah.
and said, okay, 8 has to equal 18 times d squared.
Yeah.
So 8 over 18 equals d squared. That reduces beautifully to 4/9. So d equals 2/3. How many of you figured out all 6 of those letters? Awesome. Awesome. It is impressive. It is. You got a command of what's going on. Good work. All right, I'm going to stop right here. Your homework 2-3 is due on Monday. Tomorrow, we will